still be able to hear it.
Yeah, you'd still be able to hear it. Everyone would be like, what the hell are we looking at? And I just recorded the word hell. We're off to a good start. Okay, so basically what we're going to be looking at today is actually problems that we, with our bag of tricks, we don't actually know how to solve yet. We're going to be looking at equations, and we're kind of be mixing. Best way to put it is chapter 1, which was on solving equations, with this chapter on systems, and we're going to kind of combine the two. Okay, so let me freeze the back. You still need it, and take a look at this problem. Okay, go ahead and copy it down. And what I'd like you to do is, even though this is not the typical equation that we're used to working with, I'd like you to see if you can solve it. And you might not solve it the typical way. You might have to just do maybe a little bit of guess and check. But I want you to come up with value or values for x that work for this equation. So x to the third minus 3x equals x. You already have one, Benny? Okay, let's hold off. Let's see if other people verify what you're getting to. You got an answer too? Okay. Now those of you that are getting an answer, I will tell you this is not on accident. There's more than one answer. So even if you found one answer, see if you can find other answers. Okay, so that's the first thing that makes this kind of difficult. We're going to start dealing with equations that instead of spitting out the one typical answer, you can get multiple answers here. So take a little more time and we'll see what people are coming up with. Okay. Questions, or do you guys have answers too? Okay, let's just wait. Let's give everyone else one more time. Okay, let's start off. What are some possible answers that could make this work? What'd you get, Ben?
2.
All right, so let's try that out. Everybody, 2 to the third?
6.
Oh, no. 8. 2 times 2 times 2. Minus 3 times 2, 6 equals 2. And does that work out?
Yeah.
Okay, so x equals 2 is a possible answer. But like I'm saying, because of certain aspects of this equation, there's another answer here. Anybody know what it is? Alex, what'd you get? 0. Let's try that.
Yeah, here.
What is 0 to the third power? Don't say 6. 0. Minus 3 times 0 equals?
0.
Well, I hope that works. One more answer.
X equals negative 2.
All right, let's try that. Now be careful here. Negative 2 to the third power?
8.
Negative 8.
Negative 8. The first two negatives cancel, but then there's the third negative. Minus 3 times 2, negative 2? Plus 6 equals negative 2. So 3 answers for one problem, which means we cannot solve this the typical way we're used to. Now, when you guys look at this, what do you think about this equation created this dilemma? What about the original equation would have caused us to possibly have all these different answers, whereas opposed to the typical one answer we usually get? What is different about this equation compared to other ones we've done? Francis?
There is only one variable.
Okay, there is only one variable. Okay, because we're doing something a little, well, I shouldn't say that. We are doing systems actually today. Alex? Yeah, the fact that there's this exponent here. Okay, so in your work today, you're going to see a lot of equations with elements that we have not talked about how to solve. Exponents, there might be absolute value, there might be square root symbols, and these are all things that we haven't dealt with in your typical solve the equation scenario. Okay, but now that we've learned about systems, we have another way to go about this. Okay, so here's what we're going to do. What we're going to do is we're going to treat this as actually 2 separate problems, and even though there's only one equation here, we're going to treat this as a system. So here's what we're going to do. I'd like you guys to write this part down. Let's just recopy it. X to the third minus 3x equals x. And so what I want to do is, instead of one equation, I'm going to turn this into 2 separate equations. The first thing I'm going to do is do this. Y, or x to the third minus 3x equals, and then over here I'm going to put x. And what I'm going to do is I'm just going to introduce the variable y right here. Okay. So x to the third minus 3x equals y, and y is also equal to x. Everything still holds true, I'm just introducing a new variable. Does that kind of make sense? Okay, now what I'm going to do is I'm going to split this up into two separate equations. So I'm going to take this one and write it as y equals x to the third minus 3x. And then I'm going to take this other one, which I'll underline in blue, y equals x. So here's the idea. We don't have the mathematical skills right now to solve this equation specifically because of what Alex pointed out, the exponent. But by splitting it up into a system of equations, we do know how to graph this. We still can't solve it. I can't do elimination or substitution here because I still can't deal with that exponent, but I do know how to graph this. So here's what I'd like you to do. I'd like you guys to take a little bit of time. I'd like you to take those two problems and graph them. Okay, so the first one, since we don't know how to deal with that exponent, just do a table. I would recommend these numbers. So on your paper, make a rough sketch of your graph, plug in these numbers, and give me these. And then down here, here's the other one, y equals x, but of course I've inserted in the fact that it's 1x, and the y-intercept is 0. So this one will be easy to graph, but this one we do have to put a little work into it. Now, while you're doing that though, nice thing is, I know you guys can do both these things. I know you how to graph using the table. I know you know how to graph and slope intercept. So today, we're going to let the iPads do some work for us. So once we're getting to our book work, the iPads are going to do this work for us. For the notes, I'd like you guys to do this. And in fact, as you guys get answers, why don't you just shout them out so we can give them to everybody else too. When you get the answers for these, as you plug them in, tell me what the y is, so that other people can copy them down. You got one, Alex? -2 is what? Yeah, -2 for x, but then I'm asking what's y. -2 also? Okay. -8, 6. Yeah, you're right. -2. He's right.
Oh, for x is 2, y is also 2.
Okay. Anybody got the 1, 0, -1? Yeah.
For x is 0, y is also 0.
Okay.
Yeah.
How about the 1 and -1? Yeah. For which one? -1? No, check that out. Yeah.
For 1, y is -1 or -2.
Yeah, -2. And we just need -1. Yeah.
For -1, it will be 2.
1, 3. Yep. Okay, good. Okay, so start off by graphing this one. I'll do it up here in blue. So -2, -2, -1, +2, 0, 0, 1, -2, 2, 2. Not something we're used to, right? Okay, but think about what happened there going from left to right. Started down here, came up to this point, and then it curved back down to 0, and then back to this point, and then like that. And I've got a zoomed in version of this. If that's hard to see, I'll fix it on the next one. Okay. Now this other one should be a lot easier though, because this is in slope intercept form. So somebody tell me how to graph y equals x right here. Yeah, first off, it's a straight line, right? This is a linear function, no exponent. Nikhil?
I think for -2, it will be negative. Oh.
No, I'm asking for this one. We're here.
Oh.
I'm graphing this one. Yeah.
Is this the line that goes to origin?
Slope 1 through the origin. So rise 1, run 1, rise 1, run 1. So the graph would look like this. And here's a zoomed in version so you guys can see it better. What we get is this. So now, what we're basically doing here is we're taking a single equation that we don't know how to solve, breaking it up into a system of equations which we do know how to solve, because if I now asked you, what is the solution to this system here, what would you tell me? What's one of them, I should say? How do you typically find the solution to a system when you're using graphing as your method? Typically, we've been graphing straight lines. In this case, the only difference is this line isn't straight. So what's one possible solution here? Yes, sir?
0.
0, 0, right? Right here. Okay, so let's list that over here. 0, 0. What's another solution to this particular system? Yeah. 2, 2. And the last one, yes, sir?
-2, -2.
Good. Okay. So now this is the solution to the system, but this original problem wasn't a system. In the original problem, what were we solving for? X, right? So in this case, because y is a variable that we introduced, but it's something that we added to the problem, we don't have to worry about y. We're only focused on the fact that we were trying to solve for x, so these are our answers. X is 0, or x can be 2, or x can be -2, which are the three answers you guys originally found before. Okay? So basically what we're doing is we're using graphing to get around the fact that we don't know how to deal with some of the mathematics here. We turn it into a system, we graph it, and just like with systems, we just look for those intersection points. This is a solution to the system, this is, and it gives us our answer to the original problem. Okay? Alright, so let's tackle, I think this was the only other one, right? Yeah, just one more. Okay. Now, some of you, again, who have had this math, some of you actually do know how to solve this if you've had polynomials in FOIL. Okay, others of you that are looking at me like, what the heck is a polynomial? Don't worry about it. Okay, but we're still going to try out this method. Okay? All right, so x squared equals 3x minus 2. So what I want to do once again is we're not going to treat this as one equation that needs to be solved. We're going to be treated as a system of equations that needs to be graphed. So somebody tell me, how do I split this up into two graphable equations here? Just like I did in the last one. How do I insert y and create two separate equations instead of the one equation? Francis?
No, sorry.
You sure?
Maybe it's x squared equals y squared equals 3x minus 2.
Okay, all except for the y squared part, just
Is y?
y. Okay, so what we're going to do is we're just going to squeeze this in the middle. X squared, we're going to set that equal to y. And then since y is equal to x squared, we can say y is also equal to 3x minus 2. I'm just kind of interjecting a new variable in between. Okay? So now I can split it up. So what are my two equations separately now? What are the two separate equations I'm going to graph? Yeah.
X equals y,
Which I'm just going to write it this way. Y equals x squared.
and y equals 3x minus 2.
Good. Okay. So if we've done this right, what should happen is we graph these two separately. Let's do this one in red. And again, for this one, we'll have to go back to old school. You'll have to do a table. So let's do the same numbers. Do 2, -2 through 2. And again, just so we can save some time, as you guys come up with them, just tell me what they are. Yeah. Okay, so -2 squared, +4. Nikhil?
For
-1 squared is 1. Let's keep bouncing back and forth. Oh, yeah, go ahead.
0 is
0
0.
is 0. You like that one, don't you?
Yeah. I
Yeah.
like
Yes,
that
sir.
one.
1 is 1.
1 is 1. And somebody else 2? Yeah.
2 is 4.
2 is 4. Okay, let's graph that. I'll graph it in red. -2, 4. -1, 1. 0, 0, 1, 1, 2, 4. I'm just going to sketch the rest of it. Hopefully we're going to need those points. Our friend the parabola, we've seen him before. Okay, and then how about this other one, which we'll do in blue here? Do I need to do a table for this one? No. Slope-intercept form, right? So somebody tell me how to do that one. Katie?
-2 is the y-intercept.
Okay, -2 is the y-intercept.
And then you
Rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Blah, 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 blah. I think my graph is a little crooked, but oh well. My red line's a little off. They shouldn't cross up here. Oops. Now, even though my graph is crooked, do you guys see where they intersect? And this is why also while we're using the graphing calculators today, your graphing calculator can be much more accurate than I am, or you guys can be, so we'll see these intersection points better. But for those of you that have a better graph than mine, where are some key points where these intersect? Yeah.
1, 1.
Okay, yeah, right here. Even though my graph is a little bit bad, it does intersect here at 1, 1. And there's one more place on this graph actually where they do intersect. Yeah.
2, 4?
2, 4, yeah, right here. This one, they don't. That's just my bad graphing, okay? Okay? So, this original equation has two solutions, but again, let's not get confused. We used a system to graph it, but we don't need the system type answers. Of these, which are the answers I'd actually give, not to this problem, but to the original problem? Okay?
1 and 2.
Okay, and why 1 and 2? Go ahead, no.
Because those are the x values, so there's like y value just on that.
Yeah. Y was just some artificial variable we introduced so that we could graph it, but we're not actually looking for y. So we don't care about this 1 and this 4. All we care about is the value for x. So in this equation, x equals 1. And let's try it out. Does that work? What is 1 squared?
1,
3 times 1 minus 2? Checks out. And what about x is 2? What is 2 squared, everyone? 3 times 2? 6 minus 2? Also checks out. Okay? So that's what we're doing today. We're using this idea of graphing systems to get around the fact that we haven't hit this type of math yet, but we can still solve the problems. Okay? So, even though whatever the instructions say in the book, I want you to use the graphing calculators today because I want to avoid this problem of crooked graphs. So you won't actually need graph paper. The graphing calculators are going to do all the work for you, so it's just a matter of writing down your answers. Last thing, some of the problems will ask you for answers. Some of the problems will just say how many solutions. Okay, so if the graph's a little hard to read, they might not ask for exact answers, but they might ask, well, how many solutions does this problem have? Well, it has 2, and they might not ask you for the specific solutions, okay? But that's the idea today. Tie in what we know about systems with what we know about solving equations, and this is your assignment to try to work on, okay? iPads, paper, books, I'll put up the assignment.
But I won't be able